Okay, I'm going to walk you through a tutorial all about atoms. So let's get started. Before the idea of atoms was this idea of particles. So people looked at the world around them and wondered what things were made out of. So particles, if you look at that word, the first bit should be familiar. It's just the word part. And ickles, it just literally means little parts. So you can use this word to really describe anything that's made out of little bits. So we can talk about dust particles, or we can use particles to really mean anything. But for centuries, people wondered if there was parts that were so small you couldn't go any smaller. So if we take some sort of object and cut it in half, and then cut that in half, and then cut the half in half again, and keep cutting it in half, at some point does it get so tiny it can't be cut in half anymore. And that's where this idea of the atom came from. In fact, it comes from the Greek word atomos, which means uncuttable. So there was a philosopher who basically came up with the idea that maybe there's a particle, a part so small that it can't be cut or divided further. Now, in the meantime, we know atoms are actually made out of even smaller parts, but we've kept that word. So what is an atom? Well, atoms, everything around us is made out of atoms. So atoms are the building blocks of the world that everything around us is made. Even things like the air isn't just empty space, it's got things like oxygen and carbon dioxide in it. So all of those things are made out of atoms. But atoms are incredibly, incredibly tiny. We can't see them. In fact, if you wrote a sentence on the page with a pencil, the average sort of full stop would be 10 quadrillion atoms. 10 quadrillion atoms would be in that full stop. Now that number's so big it kind of loses all meaning. It's hard to imagine that much. But if we made those atoms the size of peas, like frozen peas in your fridge, so that we could actually see them big enough, they would actually fill 1 million Olympic-sized swimming pools. That's huge. If we took a 10-cent piece, a 10-cent piece is made largely of iron atoms, so a certain type of atom, but a 10-cent piece has such a huge number of atoms in them, it's even hard just to write the number down. But if we made those the size of frozen peas, so we magnified or expanded, made the atoms inside a 10-cent piece big enough that we could see them, the size of a frozen pea, they would actually cover the planet 1 meter deep in frozen peas. And actually not only that, it would actually cover at least 11.5 other planets the same size 1 meter deep in peas. So we could cover the Earth 12.5 times 1 meter deep in frozen peas. If that's how many atoms are in a 10-cent piece. So, guys, atoms are incredibly small. There's no way we can actually see them, alright, but everything around us is made of them. So, the structure of an atom. If we look at the structure of an atom, it's made out of 3 things: protons, neutrons, and electrons. So the protons are positive, the neutrons are neutral, and the electrons are negative. Now the protons and neutrons form the core of the atom, or what we call the nucleus. The protons have a mass of 1. Now that doesn't have any value. It's not 1 gram or 1 kilogram or anything like that. It's an incredibly tiny amount actually. So we just give it a relative value of 1. So neutrons have a mass of 1, and basically what we're saying there is a proton and a neutron weigh about the same. They have the same mass. An electron has an incredibly tiny mass. It's about 0.00054. But basically, guys, it's almost 0, so we just treat it as 0. The charge, so protons, like I said, are positive, so we say they're +1. Neutrons are neutral, so we say they're 0. And electrons are -1. So the atom is organized like this, with the protons and neutrons in the core, and the electrons around the outside. And this core has a special name. We call it the nucleus. So there are actually 118 different types of atoms. So what makes these atoms different? Well, basically, the different types of atoms simply have a different number of protons, neutrons, and electrons. So they're all made out of the same thing, they're just slightly different in size or have different amounts of these protons, neutrons, electrons, the things that they're made out of. Okay, most things in the world are actually made out of only a few types of atoms. They're made out of millions and millions and millions of them, but they're actually only made out of a few different types. And we're going to look at later how that's possible. Okay, the periodic table. So you've probably seen or heard of this and wondered what it's actually about. So the periodic table is basically a list of all of the different types of atoms. So we call these things elements, but each symbol on here, like the H, or the HE over here, or the Li, each of these is a different type of atom. And each one has a different number of protons, neutrons, and electrons. They're actually ordered in their size. So the smallest one is hydrogen here, and we count across in rows. So the next biggest one is here, He. And then the next biggest one, we start the next row, is this one, Li, then this one, number 4, number 5, 6, 7. So you can see they're actually numbered in order from smallest through to, if we go all the way across, down to down here, we've actually got the biggest. Now this group hardly ever gets used. It actually fits in right about here, and so there should be another step in the periodic table, but it actually gets so wide we usually cut them out. And you really don't have to worry about this because we're not really going to talk about or use any of the ones down here anyway, at least not this year. So we can kind of just ignore those. But just be aware, the little number here, the top left, they're actually numbered in order basically of size. Okay, so let's look at those numbers a little bit more closely. In this box, we have two numbers. An atomic number is the little number, often at the top left, and an atomic mass number, which is usually at the bottom left. We've also got a symbol and a name. So one type of atom is lithium. It's at atomic number 3. That literally just means atom number 3. It's the third one on the periodic table. And it has an atomic mass number of 7. And we'll look at what those numbers mean in a second. So the symbol is just often a shortened version of the name, although sometimes the symbol is different from the name. And you've got to be really careful there. Now one thing that will lose you marks in tests, you've got to be really careful with this, guys, is the symbol is always written with a capital letter, and if it has a second letter, that's written as a little letter. The reason for that is, if you've got a capital L and a little I, it's lithium. But if it was a capital L and a capital I, that would actually read as two elements, kind of next to each other. So you've got to be really careful. If an element, if its symbol has two letters, the first one's capital, the second one is lowercase, a small one. Okay, the name is often written underneath. This one's called lithium. So what are these numbers, the atomic number and the mass number? Well, the atomic number is actually the number of protons, and the mass number is the total number of the protons and neutrons. Now remember, the protons and neutrons are the ones that each had a mass of 1. So that's just the total number of protons and neutrons. The electrons, their mass is so tiny, we don't even bother to add those in there. So that's their mass is just so tiny it would end up being 7.00. It's just not worth counting them. So the mass is based on the number of protons, the total number of protons and neutrons. So here we go. The atomic number is the number of protons. The mass number is the number of protons and neutrons total. So that is basically how many things are in the core. Now, you guys are expected to be able to draw an atom based on the information we give you from the periodic table. So if you remember the structure of an atom that I went over just before, with the protons and neutrons in the middle and the electrons around the outside, you should be able to draw an atom. Now to do that, we will give you, you'll get a periodic table and you'll have that atomic and that mass number. So I'm going to walk you through that now. Now guys, the steps are, number 1, use the mass number to draw a cluster of circles. So those are your protons and neutrons. Some of them are going to be protons, some of them are going to be neutrons. Number 2, you use the atomic number to label some of them protons. So the leftover ones will be the neutrons. Then you give the atom the same number of electrons as protons, a layer around the outside. Okay, so let's do an example. So we've got lithium here as atomic number 3 and mass number 7. So let me grab my pencil. So to draw lithium, we start with the mass number. We draw a cluster of 7 circles. 2, 3, 4, 5, 6, 7. Some fantastic circles there. Alright, so 7 circles in the middle. Now we use the atomic number to label some of those protons. So the atomic number is 3. So I'm going to give 3 of them pluses and label them protons. Protons. Fantastic. Alright, so the leftover ones must be the neutrons. Alright, now lastly, we're just missing the last little bit, which is basically the electrons. So we give the atom here the same number of electrons as protons. So it's going to need 3 electrons. So I'm going to draw a ring around it and give it, now electrons are a lot smaller. Alright, cool, give it 3 electrons. Now, my drawing here really isn't to scale. It's pretty difficult to actually work out the actual size or scale of an electron, of an atom, or the parts of an atom. But in reality, if we had an atom like this, if the proton was the size of, if we made it sort of the size of a basketball, then the electron would actually be the size of about a speck of dust. So that's about the relative size. So electrons are actually a lot smaller. But if we drew them like that, you wouldn't be able to see them and the diagram wouldn't be very clear. So we have to draw them a bit bigger so you can actually see them. Also, the distance between these, between the proton and the electron, is actually a lot further. So again, if my protons were the size of a basketball, my electrons the size of a speck of dust, they would be several kilometers away. So we're obviously not going to be able to fit that on a page, and again, that's not going to make for a very good diagram. But just so that you're aware of the fact that, you know, this isn't really to scale. But anyway, let's run through that one more time. So you take the mass number and you draw a cluster of circles using the mass number. Then you take the atomic number and you label or add a plus, label them protons, that many circles in that cluster. So we had 7 circles, we label 3 of them, in this case protons. Lastly, we add the same number of electrons as protons, so we use the atomic number again. That gives us 3 electrons for lithium around the outside. And I should label those. So electrons. And also we could even, and I might just change color for that, alright, we could even label the entire center of the atom, the core, is the nucleus. Cool. Alright, so that's how you do or draw an atom. I hope that helped. Okay, so I'll just wipe that and hide that. And now we can, now we can get on to the next bit. So sometimes in a test, you'll actually just be asked to work out the number of protons, electrons, or neutrons. So we won't actually ask you to have to draw the whole thing. And at some point, guys, rather than having to draw the whole thing every time, it's going to be useful if you can actually just work out, you know, the numbers of those things. So that's where we suggest you learn this, P-man. It's a little bit of a trick to help you remember. So protons and electrons, you just use the atomic number. So protons and electrons equals atomic number. If I'm trying to find out the number of protons, just use the atomic number. Lithium was atomic number 3, it's got 3 protons. How many electrons does it have? 3 electrons, atomic number 3. Cool. The next bit, mass number minus atomic number equals neutrons. So if we take the mass number, the big number, or the 7 for lithium, minus the atomic number, the smaller number, the 3, gives us the number of neutrons. So 7 minus 3, we had 4 neutrons. And if you remember the drawing, that's correct, we had 4 neutrons. So it's the total in the middle, the mass number, minus the number of protons, the atomic number, the leftovers, that's your neutrons. So P-man, protons, the P, and electrons, E, equals the atomic number. So that's your P, and the mass number minus the atomic number is the number of neutrons. Okay, alright, so that's basically it. I might just go through one more example using our P-man. So if we pull out another element, so let's pick an example. Alright, so sodium is a funny one. It has the symbol Na, and its atomic number 11, and it has an atomic mass of 23. So you'll see sodium in a little square like this on your periodic table. So to draw it, we would draw 23 circles, label 11 of them protons, and give it 11 electrons, and then label everything. But let's just use our P-man. So if I want to know the number of protons, the number of protons is just the atomic number. So the number of protons is 11. Now the number of electrons, remember P, protons and electrons, equals the atomic number, so it's the same. It's 11 as well. Now the number of neutrons is the tricky one. So the number of neutrons, alright, is the mass number 23, take away the atomic number 11. So in P-man, the man, M-A-N, is the mass number minus the atomic number equals our neutrons. 23 take away 11 is 12. So it's got 12 neutrons. There we go, perfect. So protons, remember, are the positive ones in the middle in the nucleus. Electrons, the negative ones flying around the outside. And neutrons are the neutral ones in the middle of the atom. Now only the protons and neutrons are big enough to actually give the atom some mass. The electrons are so tiny they just hardly weigh anything. They give the atom like hardly any more mass. So in terms of the atomic mass, we just take the protons and neutrons. We don't count in the electrons. So that 23 you can see there is just the 11 and 12 together is the total number of things in the nucleus that actually give the atom some mass. Cool, that's everything. I hope that tutorial helped, and good luck with your study for your test.